Dude, these are beefy dampers. Look at that.
Last time on Rallye Cayman, the boys reworked the entire Porsche cooling system, custom designing new parts to make our car rally capable. Now comes one of the more important items in the world of rally: suspension. The entire geometry and design of the suspension needs an overhaul. So hang on, because there's a ton to do, a lot to learn, and only 5 days to get this car on its new wheels and ready to drive.
Alright, so here we are with the Cayman. As you can see, we've removed the springs from the car, but the suspension is assembled otherwise. Alex printed this awesome little wheel out, which we were testing with brake fit and stuff, but right now we're actually going to use this for offset and making sure we have the right offset when it's compressed.
This cross section of the Braid wheel has removable mini sections, and this represents a plus 45 offset, plus 30, plus 15.
Working backwards from visions of sailing through the air in our Cayman, we had to get a baseline of what the factory suspension travel looked like. Braid Wheels graciously gave us a cross-section drawing of their 15-inch rally wheel with different offsets. We used that to print a model that represents the actual clearance we've got to work with. Might seem like overkill, but you might notice just how thick the outer barrel of the wheel is with extra reinforcement ribs. This is not your average wheel. We quickly realized why no Cayman before has used big off-road tires. The tiny wheels interfere with just about everything, including the brakes and, most worryingly, the rear tow arm. This is a huge issue, as moving the rear tow arm placement forward to clear the wheel means the tow arm pickup point on the subframe has to be moved forward too. Without moving that pickup point, the tow gain as the suspension moves up and down would cause massive amounts of bump steer. We were scratching our heads back and forth with ideas of custom machined $5,000 uprights, custom brakes. Nothing seemed true to the theme of the build until Nate had a stroke of genius.
These are both McPherson struts. They both share the same control arms. They're pretty basic. Why don't we take the left front and put it on the right rear, and the right front and put it on the left rear? Because we know we can fit a 15-inch wheel over this toe length. We know that the caliper spacing is about the same. We know that the strut diameter is the same.
Control arms are the same.
Pretty much everything is the same. So Alex came over here. Obviously, you see his handiwork with his spring and his little pasties all over that. So let's take a look at what Alex is working on right now.
So this is a scan of the rear and the front overlaid, and I have another scan of the rear with this flange on it. And if I pull that up with the front, it's literally identical.
Dude. So we got a view is Lewis, and which one of you is Clark?
He's Lewis and Clark. It's literally perfect. This will work, and check that out. There's our Braid wheel clearing. So this is the cap on the front wheel bearing hub, and then the pink is the rear with the axle and bearing removed. And as you can see, the cap literally is sitting on the same. So literally, if the whole thing is just clocked, which I've done sort of here, it's the same pickup for the bottom and for the top. That's awesome, dude.
Nice work, boys.
This is good stuff.
My day just got a lot easier.
Yeah, let's go get milkshakes. That's what's important.
Day done.
Right. So this is the new front unit that is now going to be a rear unit with the smaller toe link here, so we can actually hit those 15-inch wheels. And then this is the standard rear that came on the car. So you can see how much longer this is. That's really why this is advantageous to us, is to reduce this distance so we can fit those 15-inch wheels over it. This is a rear-wheel drive hub, so this has a place for the axle to go through with the splines. If you look at this front hub, you can see it just has this sort of black-off plate. It has room in here, but there's just a block-off paint. So what I did is I popped it off on this one, same thing as this one over here. What lives in here is basically just a little stub axle. So it's really just to preload the bearing, hold the bearing races tight together, and it has even a little bit of a spline on it. It's a small one, doesn't do anything, but a little bit of a spline. So with that said, that allows me to take this front upright that would normally be just having this go through it, not do anything, bring it over here to where we have our rear axles, and I can actually show you how the axle goes right into this front upright, hooks to the existing upright and spline and would drive the rear wheels right there. So it really shows how cool the similarities between all these cars are and how much we can utilize sort of Porsche's engineering and just kind of reconfigure it to do what we want to do with this car. So now theoretically we know that these front uprights are going to work on all four corners of the car. Next step is to bolt them on the car and put the wheels on, lower this thing down and see it in action. Let's open this up. We got some special delivery from Braid. I am very excited for this. Oh, I know. Look at like you want to see this. Like A, it's machined. B, there's steel inserts in there to spread the load. And like this is the sort of wheel that like you get a puncture and you just drive for the next like 100 miles on gravel and rocks and just get there and the wheel still exists at some level. The fact that it says Acropolis on it just makes it that much cooler.
It looks so good.
Just got these back from Mr. Rob over at Thunder Performance. He bored them out for us. So you can see that they're all nice and freshly bored to a slightly 1 millimeter larger diameter. Oh, nice and snug. Oh, that's such a good feeling. So this is a rear rotor, not a front rotor. Sorry for the background noise. Our video editor, producer, Stephen Cole, is actually mounting up our Braid wheels with our new Rallye tires. So air compressor's running. The brake caliper bolts right up, the brake rotor bolts right up. The only difference is the distance is slightly different, basically to centerline, so we can easily correct this. Now we're just gonna add some washers to space it out. When we finally build this thing, we will make a nice square piece that properly fits in there. Perfect. This is a full front upright on the rear. And now, my favorite part, and the part I've been very excited about, I'm gonna bolt this wheel on. I just want you to think about this, the shot we got at O'Neill, like right here, of the burnout. And I just want you to think about that with this in gravel and more noise and more suspension. And it's the moment of truth, putting it on the ground for the first time. Like we even graveled up the ground to make it feel more at home. No, we're good.
So the knuckles fit and the new wheels are looking tough. But this is just a mock-up. There's still quite a bit for Nate to tackle in order to make his plan come together. Like building up custom Rallye coilovers, designing the rear subframe to fit the new knuckles, and adding fresh arms and bushings.
We're going to be using Mila as our suspension arms. So these are the standard control arm from this car and the standard right here. But this is a really nice unit. These are OEM quality. You can see here we have a spherical bearing up on the front. They're all aluminum. And one of the really cool things about this car is this carries basically the same control arm front and rear. Now, in addition to that, we're going to have a little extra travel. This is the Tarmac suspension that's in the car. This is a Bilstein PS16, I want to say. But you can see it only has about 4.5 inches of actual travel. That's not going to allow the wheel to move all that much when we're actually going down those gravel roads. And if you think about the big rocks and the dips and the jumps that this car is going to be doing, we want as much travel on this as physically possible. That's where this Bilstein 50 millimeter damper comes in. So this is an actual gravel damper from Bilstein. It's a universal fitment, so it's made for basically all different types of cars. You have to modify it to make it fit your car. You can see we have a significant extra amount of travel. So this is about almost double the travel of this front damper. You can also see that the diameter is significantly larger. If I hold those two up next to each other, let me kind of walk you through some of the design process of how we're fitting these dampers to these uprights to make sure we have a bespoke gravel setup for this car. So right here we have the standard damper up on the top. This is just a really quick model made of it, and then we have a more elaborate model of the actual motorsport damper that we're using. Now, taking the standard one, I basically bottomed it out fully. So basically fully compressed, what does that damper look like? And then I've made a reference down to the gravel damper that we're gonna use from Bilstein and bottomed that out fully. Now doing that allows me to draw a line between the two and realize how much we need to machine up the bottom of the gravel damper. So basically what we're gonna do is machine this to allow that to slip into the aluminum upright and make sure we have the correct ride height and the correct droop when the car is fully compressed. We're gonna have nice aluminum top hats made. We're gonna have these awesome Bilstein gravel dampers. We're gonna have them machined up here. We're also gonna machine the top here. It's really cool that Bilstein does this because they allow us to really do some of the customization on this product, but also there's parts of this product that we can't build ourselves, which is the actual damper tube and stuff of that nature, which they do for us. Once we have that stuff sent out, we should be seeing this stuff coming back from the machine shop in 2 to 3 weeks, and we're gonna be 3D printing a couple components, test fitting it all in the car, and basically verifying that everything I told you here actually comes true when it's bolted on the car. All right, so what we're doing right here is prepping the metal here to weld on some really awesome 1/8" plate reinforcements for the top of the strut housing. This is really the first direct point that the suspension attaches to the car, and definitely under a compression, that's where all the energy is gonna be pushed up into, or most of the energy is gonna be pushed up into. So what we're gonna do is we're gonna have these plates that Alex designed. They're gonna be going on here. We're gonna bolt them through. And what that's gonna do is it's really gonna take the load from the suspension top mount and kind of distribute it around broader area versus just coming through the sheet metal where we often see these crack or bulge or whatever. This is a pretty highly stressed part of the car, especially on a rally stage. So we're gonna do our best to basically reinforce it and make it a lot stronger. So with the driver's side down, we're gonna head over to the passenger side, and then we're gonna do the rear. We're gonna go all around this car and get them all jammed up and ready to go. So we just got our suspension back from machine shop. So we got the universal 50mm gravel dampers from Bilstein. We machined them down, we machined the uprights, made everything match. Obviously we have 4 front uprights because that's how we're gonna run it. You can see this is the rear. We have enough clearance for the axle to come in here. And we're gonna run a 14-inch long I-box spring on there. This is the front. You can see that on the front, it's gonna drop down a little bit further in the car, basically right down to almost where that ball joint would sit. But yeah, this is the front setup. Same amount of travel, just it's obviously there's not as much height on the front strut housing as there in the rear in this car. We should put a spring on it. It's like a kid that can't shove. Safari what?
That's Rally, baby. So sometimes
Rally problems.
stick.
There you go, front and rear gravel dampers.
So there's a whole kind of reinvention of the braking system that we're going to be going through here. And right now what we're gonna do is we're gonna start locking these items down in the car. Rally cars are known for getting the bottoms ripped out from under them, and on most street cars, the brake lines are pretty sensitive and run down the bottom of the car. The way we do it on rally cars is we're actually going to plumb soft lines inside the car. So keep it away from harm's way, up inside the car, and also allow us to plumb it in a little bit more efficiently. First things first is we're going to start at the core where the brake system starts. So the pedal is going to be pushing on this, and then the balance bar is going to be pushing on the master cylinders. We're going to get this mounted up to the car, make sure it fits right, make sure the pedal is attached to it, make sure we have the right swing, and then we'll work our way out from there.
Now that the Rally dampers are built, we're switching gears to plumb in the new brake lines. We'll jump back to building the rear subframe, but it's a good time to ensure that the lines are in the right spot and the calipers clear the wheels.
The other thing that's really cool is there is a backup brace on this right here. So that is going to cross this over, because imagine as you push on that pedal, there's a significant amount of force going into this. All right, so now we have the pedal linkage hooked up to our actual brake pedal. So you can hear the brake pedal hitting its top stop and its bottom stop right there. And you can see we have the balance bar hooked in here. So now obviously there's a place for both master cylinders, the front and the rear master cylinder, to go. And you can see this balance bar has the pivot point that actually can slide back and forth in here. So as this turns, this actually changes the location of that pivot point. As this right here moves back and forth, it is changing the percentage of force between this one and this one. And that's how you change the bias front to rear. Now to do that in the car, so you have this knob, and as you turn it, you can see this end is turning. So as that end's turning, it's actually screwing this thread portion back and forth, which is shifting this center locator back and forth across that tube, which is going to be changing your bias between your front and your rear master cylinders. So this gives us full control of the brakes from inside the car. So we're using some of the best here. These are AP Racing master cylinders. They have this nice little zip tie on there. And I've also put an F. This is going to be our front master cylinder. The other one will be our rear. Now, oftentimes these need to be trimmed down, and clearly this is the case here. And we need to have, our shaft can't be any longer than, I'd say about 85 millimeters, both sides. So what I'm gonna do here, keep the boot on here. I'm gonna take one of the nuts off. And then what I'm gonna do is off of the face, because that's where I measured. I'll measure out 85 millimeters, which is right there. We're gonna tape it up, and we will cut the taped portion right off of that. I'm going to do the same to the rear while I'm in there. All right, to the saw we go. I prefer when I turn the knob to the right in the car that it to have more front bias. That's just what most of the cars I've driven have done. As we turn it to the right, it spins to the right. So now if I take that, and you can see this end where that's going to attach to, if I thread this to the right, like that, fulcrum point is moving over to the right. That means I'm putting more pressure over on this side. So we're gonna put the front over here, because that will be basically the same that I expect of turning to the right is front, turning to the left is rear. What we're gonna do, I've left one nut on there as a lock nut, jam nut, and I will thread this in. So you can see our balance bar is relatively flat right across, so perpendicular. That's how we want it, between the two, front and rear. Breaks off.
You got the engine near, and then the engine is near.
Oh, God. Jeez.
I'll be here all week.
Unfortunately. Well, next week you're not going to be here.
Yeah, it's gonna be so nice. All right, so now we have the caliper, and we obviously have the master cylinder. We need to connect the two, and we're going to be running new brake lines that are gonna be soft throughout the car. So first thing we're gonna do is we're actually just gonna pop the old standard line right out of place here. So you can see this is the standard line. I'm gonna take this stuff off, and we're gonna just throw it in the trash. Brake lines never cease to amaze me. You can have them apart, have them sitting there empty for 16 years, and you break a seal, and they still leak a little bit of brake fluid every time. So this is just some cable, and this does a fabulous job of measuring lengths. So say if we go down here, we go back up here, we're probably gonna have a 90-degree right passing through here, holding onto this. And then this needs to have some slack and go to the caliper just like that. So now looking at this, we can say, okay, now I can move it up like the suspension was going up, move it down. You know, we can actually go ahead and steer the car. So, going out, make sure we have enough slack built into that. Now, if we know we're good, then we can take this out. We can measure this length, and then we can order our brake line to whatever this length is. Now, moving over to the rear, we're gonna do a similar manner. So there is actually the standard location where the brake lines pass through, right here. We are gonna do the exact same thing again. So I'm going to sandwich some washers through here. And we're going to put the brake line sort of in the downward position here. Moving to the inside of the car, we are also going to be installing the handbrake. So we have the handbrake on the table. Obviously that's gonna go in the middle. So as we start to move from the rear master cylinder through the firewall, we're going to plumb that brake line right up through the master cylinder for the handbrake. And then that's going to continue back. And somewhere above the engine, we're gonna tee that off. We're gonna go to the left side wheel, we're gonna go to the right side wheel, and we'll have the entire brake lines basically plumbed out and ordered in this car. I'm really doing here basically is connecting all of the dots. So these are all the places where it's going to go through the sheet metal. So you can see we obviously have a T right here where it comes through. Now we're working on the brake lines going into the cabin that are going to run through the hydraulic handbrake. And then they're going to run from the cabin to the rear of the car where they're going to go get splayed out to either rear wheel. Obviously running all the brake lines in safe, easy, accessible places once the car is built. It's like, yeah, it's like every kid, like the choo-choo train of yesterday, it's like, you know, choo-choo train, this is gonna be like, skids. All right, so what we had done early on is we had taken the rear brakes and thrown them on the front because they're smaller diameter. You know, rear rotor's a little bit smaller. When I go and put this Cayman non-S caliper on here, it like almost meshes up, but there's a little bit of a gap still, and you can see the pad is actually touching the bell of the brake rotor right over here. What I'm gonna do is quick undo the set screw. I'm gonna plop this rear rotor, which we popped on the front. Remember, we were kind of figuring out how much of this stuff is interchangeable front to rear because these spindles we're using in the rear anyway. A rear S rotor is the same as a front non-S rotor. That's Porsche being Porsche for you right there. So, test fitting this, get this guy on. Left side, we're vented the right direction. Obviously, you always want your vents, you can see these are angled vents. As it rotates, you always want it to pull air into the hub and expel it out. A lot of people put them on backwards. A common mistake, you definitely don't want to do that. Then we have the caliper, and as you can see now, this caliper bolts on without an issue. All right, braid wheel time.
Look at that.
There you go, 15-inch wheels, non-S brakes. Send it all day long, bolt-on solution.
Excellent work. Good job.
This is all awesome, it's coming together.
Yeah.
So we have rear rotors here, and we have the calipers, and basically what we're gonna do is the exact same thing we did on the front. We're gonna bolt one of these suckers on. We're gonna verify that we have clearance. The diameter is about the same, but you can see it has a significant width difference. So this is the 24 millimeter width. This is what the standard S models would have. The non-S models have the same 299 millimeter rotor, but it's a 20 millimeter wide. Ugh. The rear rotor bolt on nicely. Remember, this rear rotor is actually being bolted onto a front upright. So it's good to see, first off, we don't have any clearance issues. So we are having a little bit of contact over here. That is probably due to the fact, and easily solvable, that this is a rear caliper going on a front upright. And while the side-to-side spacing is right on, as I can see, this is located right in the center. The bolts that are bolting the caliper to the upright, the bosses are a little tight, so we're gonna have to run spacers underneath it. They're machined down a little bit lower, more towards the center line. So what we can do is we can run little spacers underneath this to push the caliper outward a little bit, and that will make sure we don't have any contact. There you go. So moving that out about 2-3 millimeters allows us the clearance we need. Nothing's binding, nothing's hitting. Oh my God, this thing is heavy. Looks pretty good. I am removing all of the old brake lines. So obviously we're running brake lines inside the car, like a real rally car, and just want to get these out of the way. So that's going to allow us to really see what this thing's going to look like. Next thing would be power steering lines, just basically clear it all off. Less stuff under here to get ripped off. Timber! So our power steering, get the power steering group out of here. What a mess, huh? Clutch line we're gonna leave for now. I would like to see it go away. I'm gonna put some P-clamps on it and hold it really nice and tight up against the floor. Yeah.
Okay, so one of the most difficult parts of this entire project, at least for me, has been this piece right here. This is where the engine bolts to, it's where the transmission bolts to, it's where all the suspension arms pretty much bolt to except for the forward trailing arm, and it's extremely intricate, and it's, unfortunately, it is very thin aluminum. Of all the things I've ever engineered, of all the things I've ever designed, it's a very difficult thing to take something that's cast and kind of organic and make it into sheet steel, especially when it has this many jobs to do. So this right here is the part off the car. You can see that it's a crazy mesh of draft angles for casting, and I was tasked with making this entire thing out of sheet steel. So this is what I came up with. It kind of looks like a Fisher-Price toy set, but that's because there's so many parts that I had to color code them so I can even know what was going on. Because we're running a front knuckle on the rear, we ended up moving the toe arm inboard of the center line of the wheel quite a bit. Right here, you can see where the blue is, that's the original part, and then where mine has been moved over 37 millimeters, which is how much it needs to be moved over for that arm to clear.
Oh my God.
All right, so now that everything's here, I'm just gonna start by laying it all out on the table, and I'll probably go through and label them, which ones are for which side, and then it'll be the tedious process of just fitting things together, making sure they fit right, and we'll go from there. Look what you've done.
This is like coming downstairs to my house and watching like my 4-year-old trying to put a Lego set together, just looking at all the blocks going.
Yep, and it's even worse because if any of it doesn't work, it's my own fault. It's like I can't yell at the IKEA furniture designer anymore. I am the IKEA furniture designer.
You don't have the...
Nothing in here. Oh, look at that.
It's a puzzle, and when you click it together, it equals still a puzzle that I have to weld. Here. This goes like that. These are bushing jigs to make sure that I don't clamp anything tighter than the actual physical bushing is on the car. So I'm gonna cross my T's and dot my I's and crack out the welder, I guess. For anybody actually wondering about the material itself, this is a 1008 cold rolled steel, so it's a little bit stronger than hot rolled material. So if you look at this line right here, it is technically clipped in and welded, tacked, but if I clamp it down, you'll see that that line gets a heck of a lot smaller. And now I can weld it. Now I know that it's probably pretty close to what I actually have in CAD.
With a shortage of time and trying to stay true to our DIY roots, we didn't want to make a fully billet rear subframe for this car. This assembly is self-indexing, so we also didn't need a fancy jig to fab this up. Yes, there are much more accurate ways to make something like this, but for only a few $100 in sheet metal, we had Rallye-ready steel subframes that could accommodate our geometry changes.
This and this match. So you can also see that how much we've moved in the toe arm. So on this one, you can see this circle at the base here, that's where the engine mount is. This is all flipped upside down. And then it comes straight up and down. And then this is the rear toe arm mount. And on ours, we've moved it over 36 or 37 millimeters. You may be wondering, how am I gonna get this piece out? I'm not. I'm gonna leave it in until the very end, and then I'm going to destroy it and take it out that way. So that's starting to look pretty good.
So I'm gonna finish weld them all once everything is put together. There's this kind of crazy looking thing, and this connects not only for these 2 studs here, but it connects on the top and then into this hole down there, and then that is the sway bar mount. This piece has to line up with all this stuff, and then this piece has to line up with all this stuff, and then this has to line up with all of them, and the bends have to be correct. So the fact that that just fits makes me very, very happy. That's that side. Actually pretty much done. Well, aside from the eccentric things, but pretty happy with it. Now onto the other side. I'll just have to make sure when I do this again that I don't put too much weld there, because that's, I think, about the limit. There's 2.5 millimeters there to spare, so. I will assemble this onto the mount, and then we'll go ahead and throw it on the car. It looks like the part doesn't fit well, but it's just because it's so heavy I can't hold it up. Look at that, that's like way better than the toe was before. It's nice and straight. Success. These 2 little tabs on the side act as the eccentric stops. That works just like factory. All right, I'll do it all again. Yep. I learned a lot doing this one.
We're gonna do some Bilstein building. So this is basically the same way that all Bilsteins are made, or at least monotube Bilsteins. But we actually have to do it ourselves because they kind of, expect you to be able to either weld on this, machine this, whatever it is you have to do to get it to fit. Obviously, we machined it. Our 36 millimeter socket is going to act perfect as our seal pusher. So first things first though, I am gonna fill this guy up with grease. So the grease kind of lives between the bearings and just kind of just coats this outer tube right here as it goes up and down, and just make sure everything stays nicely lubricated. We have our bump stop installed. Now just straight through, try to keep that bump stop from getting super wet. Smearing the oil through. You can feel the difference in the damper.
Screw it, so let me just, I'm gonna learn how to weld.
Very happy. You can see how firm everything is all the way up. We'll put the top seal on, put some lube on that as well, and we'll be ready to go. So yeah, everything looks happy. Making sure the bearing placement's where it needs to be. Put this top seal in. Yep, 1 damper down, 3 to go. 1 support down, 1 to go. So when I developed the initial suspension for this car, I actually sort of undersprung and underdamped it on purpose. First off, because I want to accentuate the gravelness of the car and let it squat. But it's also really fun because now I look at this and I'm like, these springs, like as soon as this car hits the ground, as soon as you hit the brakes, it's gonna dive, it's gonna squat. It's just gonna be like a big trophy truck. It's gonna be so much fun. Let's build another one out. We got another damper tube here. These dampers are all the same front and rear. The only difference is how much machined they are. So this is a rear. This is a front. So you can see that the same exact travel, same exact everything, except the machining is different to allow them to be accepted into different suspension uprights on the car.
Looks like a shock, dude. That's shocking. I'm impressed that you pressed that together.
The fact that Bilstein still makes these, it just shows how cool of a company they are, in my opinion. Yes, they're OE and they have a bunch of bolt-on parts for all of the cool European cars in the world, but the fact that they're like, hey, there might be some dudes that want to go racing that don't have a lot of money. We're gonna set them up with a suspension package that they can build themselves. Stand-up stuff right there.
Yeah, it's done. Oh, no, it's not done. I have to cut these tabs off. God damn. It is time to frickin' paint this thing. I can be done welding. My fingers can return to normal temperature. this is why CAD is awesome. I made this little cutout here, and it fits just enough.
Oh yeah, these are starting in beautiful. Yeah, I think we basically build the box a little bit loose, square it up, and then snug everything down.
You are totally right. This is one of those moments where box everything in, you start to understand like the birdcage mentality of Porsche design. It's like you put all the dumb little tiny 1 pound aluminum braces on and suddenly you have something that's as strong as a giant cast iron piece.
There you go. And
Is that the correct?
yep, I could get a bolt in there if I had to. We have 5 days to finish this car, and you coming over with this is like the best thing in the world for us.
And that's why it's all about the goodies.
Oh, thank you. Thank you so much.
There it goes.
Obviously, this is where the cage was welded to the tower, and it's kind of all tied in. So as we go through this, we have some self-etch primer. I'm going to wire wheel this real quick before we fully assemble and get this all cleaned up so it's ready to go. So I think the next thing is let's lean over on this side and let's start to piece together the suspension on one side. And then hold on, let me get this slid. Whoa! Whoop, 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 whoop.
There it is.
For the first time.
Just fit.
It just, look, it like shaved the paint off the corner, and that's it. Yeah. I'm gonna pull this off and I'm gonna put the upright on. So we wanted these really big, thick tops on here. This is a common place where dampers actually break out. So we want to run some big sphericals. So we have these guys. These are big Aurora bearings, spherical joints, and that just fits in just like this. If you actually look through here, you can see there's a little bit of a groove right there. So we drop that through, and then we have this really cool, this is called a spiral snap ring. So rather than a snap ring that's like a C, that covers like 3/4 of the area, this will actually cover the entire area, really making sure it can't back itself out. So to install, you kind of just thread them in. It's a little tricky, but so there you go. So it just basically spirals right into place. Now we have a full fit. And if I were ever to want to pull this back out, I just need to get a pick, get under that edge, and I can reverse the process and spiral it back out. So good stuff. Now I just need to bolt it down. Fitting big suspension on a little car is always hard. I'm preloading it the way, because I had to unload it to get it in there. Yeah. Which is probably about there. So that's gonna go there, and that's going to space the rear damper up a little bit. Make sure we have clearance on the axle boot. I'm going to be ripping out the front suspension real quick. So we'll be changing the control arm, track rod, tie rod, all that sort of stuff in there. And we'll be able to actually bolt on the front suspension properly for the first time. Stuck. back in the abyss. What I'm going to do is I'm going to cut this down, and then we'll put the nut on here. So basically it needs to be cut right there. Put some longer fasteners in the top, we'll wiggle it all tight and should be good. Look at that. Look how close that comes. All right, so we got the brake lines here. Isn't it amazing when the plan that you actually anticipated to happen actually comes true? You like that nice little loop back in, tucked right in the valley.
There's going to be about 40 pounds of coolant that's going to go in the front, so. That's the best thing JR and I have ever done.
You get that?
Yeah, it'll go to 0 once it's at.
It was a really good shot. Dude.
This, amazingly, the side skirt's actually almost flat.
The Rallye Cayman is finally looking proper, with its fresh off-road stance. Next time, Nate and Alex push to get this car completely buttoned up and running. The West Coast is calling, and it's almost time for Overcrest Rally.